Now, when we are talking about this equilibrium of rigid body, let us talk about couple in order to understand rotational equilibrium a little better. So, what is a couple? It is a new term now. Couple is a pair of equal and opposite forces with different lines of action. This was the example which I was mentioning, right? You have equal and opposite forces because of which the net force is zero. But these two forces are acting along different lines. As a result, there is a rotation which is happening. So this results in rotation without translation. So it results in rotation without translation. Let us look at the same example which I mentioned before. You have this rod, you apply equal and opposite forces on both ends of the rod. So what will happen? This force will try to take it up, this force will try to take it down, and as a result the rod will start moving in anti-clockwise direction. So rotation will happen, right? That is what happens. So the rod will start moving in this fashion. So these kind of forces is known as a couple. That is a pair of forces. Couple is always a pair of forces which are equal and opposite, but they are acting along different lines of action. Right? Now the same thing in case of this is applicable, and some of the practical examples of couple is your door. Why do you have this door opener on this end and this fixation on this end? So that a couple can be formed. So when you push the door from this end, you are applying a force here, and since it is fixed on the other end, there is another force which is operating here. So two equal and opposite forces will help the door to rotate, right? So have you ever seen that the door has this door opener at this end? No. Right? So similarly, when you open a bottle, not only with a bottle opener, but also when you try to open the cap of a bottle with your hand, you just move it. How do you move your fingers? If this is the cap of your bottle, on this side you apply force in this direction, and if this side you apply force in this direction, and that is how you open it. Right? So these are some of the practical examples of couple. Now because of this couple, so the couple plays a very important role because of this couple, torque comes into picture, and as a result rotation takes place. So let us look at the principle of moments for a lever. Now when I say principle of moments, what do I refer to when I talk about moment? Moment here refers to moment of force, and moment of force is nothing but torque. Right? So let us take the example of a seesaw, which you often see in children park and all those stuff, where you have a straight rod like structure where you have two seaters on the two ends, and there is at some point there is a fixed point between the two. Right? Now this point is known as fulcrum. So fulcrum is the point around which or about which the two ends move with respect to each other, right? So now let us suppose that a force F1 acts at this end, and there is another force F2 which acts on this end, right? Let us suppose, when two children sit on the both ends, let us suppose this is the force applied on this end and this is the force applied on this end. Now because of this fulcrum, there would be a reaction force in the opposite direction that is given as R. Let us suppose the distance of this is D1 and the distance of the other end is D2. Right? Now in order for this lever to be in equilibrium, so for mechanical equilibrium, we have to ensure that there is translational equilibrium as well as rotational equilibrium. So when I talk of translational equilibrium, I mean that the net force should be equal to 0. So what is the net force here? R is the force which is acting upward, right? So R minus F1 plus F2 which is acting downwards. So this is the net force acting in this system. So this should be equal to 0. So this implies that R minus F1 minus F2 should be equal to 0. Also, it should be in rotational equilibrium. That means the net torque should be equal to 0. Now, what is torque? Torque is given by R cross F. What is R? R is the position from the origin. So, here fulcrum is considered as the origin. So, that means the torque at this end will be equal to D1 F1 and the torque on the other end will be equal to D2 F2. But in this case, the direction of the torque, in this case, what is the direction of the torque? R cross F. That means R cross F. So if you curl your fingers in this fashion, you get the direction of the torque as your thumb pointing towards yourself. Whereas in the other case, when you point D2 cross F2, you see your thumb pointing in the downward direction. That is opposite direction. So therefore, here D2 F2 will have the negative sign because in this case, torque is in the opposite direction. Right? So this will be equal to, this should be equal to 0. Right? So now this equation is a very important equation. So in this equation, we call F1 as load. So F1 is known as load. F2 is known as effort. So this is my load. This is my effort. So therefore, this distance, the distance of the load from the fulcrum is known as load arm. And the distance of the effort from the fulcrum is known as effort arm. Right? So therefore, we can write this equation as D1 F1 is equal to D2 F2, or this can be written as, so this can be written as load arm into load is equal to effort arm into effort. And this defines the principle of moments for a lever. So to ensure rotational equilibrium in case of a lever, we should ensure that the load arm multiplied by load should be equal to the effort arm multiplied by the effort. So we often define another term known as mechanical advantage, which is abbreviated as MA. So this mechanical advantage is the ratio of load to effort, that is F1 by F2, which is also equal to D2 by D1. So this is how we define mechanical advantage of a lever. So mechanical advantage of a lever is the ratio of the load to the effort. Right? So using how this mechanical advantage helps us, because if the mechanical advantage, if the value of mechanical advantage is very high, that means F1 is very greater than F2. That means a large amount of load is required in order to get a small amount of effort. Whereas if the mechanical advantage of a lever is very small, that means that F1 by F2 is very small. That means F1 is very less than F2. That means a small amount of load can give you a huge amount of effort. Right? So this is how we define mechanical advantage of a lever. So when mechanical advantage is very greater than 1, that's what I mentioned just now, right? So when it is very greater than 1, that means F1 by F2 is very greater than 1, which means F1 is greater than F2. Similarly, here when it is less than 1, this means F1 by F2 is less than 1, which implies F1 is less than F2. So here it implies that large load will give rise to small effort. And here it implies that small load will give rise to large effort. Right? Okay.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more.